Hi, my name is Vitali. I want to present my view on precession. This is a result of the hard work, and my presentation consists of two parts. First part is precession as standard inertia effect for spinning object, where I want to prove my view on precession, and second part is for precession's theory, which in my opinion is describing everything whatever happened with the spinning objects. So let's go. And the first time I saw the spinning top toy was when I was a kid, and it was looking for me as magical and mysterious. Why spinning toy not falling down, and why it's moving like this. So it seems like in our genetic installation disk, this information about precision is not included. And later I was searching for explanations, and I was not satisfied. And I have more information, and after time I decided to find my own explanation, and I found it. And this explanation should be easy, simple, and very, very clear. And calls like phenomenon should not be included. My explanation use only Newton's law of motions and some logic. Like in computer programs, if we go down to the lowest level, there are only ones and zeros, which are synchronized and coming in order. Only 1 and 0 coming in genius order can create a magnificent things, and like entire world inside the small chips. Here I want to present this picture what I have. For my explanation, I assume there are some following conditions. So spinning body is a disk, is the flywheel. Center of masses is at the spinning axis. Flywheel have sufficient spin so that gyroscopic effect is vivid. The torque applied at the top to positive direction axis X-ray, and at bottom at negative direction minus axis X-ray. Torque speed sufficiently lower than spin. I use coordinates for positioning, and I was assigning single molecules at outer edge of the flywheel, which is on top, axis 0. The first is on top, and each next is positioned at 30 degrees from previous. Also, I assign molecules uh, as part of the flywheel, but consider it independently. It's something like flywheel minus molecular 1. Why is molecular 1? I assume the flywheel has a rigid body. I consider it only semicycle, because opposite semicycle of the flywheel has the similar effects, but only forces going to opposite direction. And flywheel is absolutely free to turn in any direction, and speed vectors which I show on my diagrams are momentum and schematics. And changing of flywheel engine angle is not considered during shifting of molecules. Now the sketch. For explanation, I make drawing of flywheel in two surfaces, front surface Zulu Yankee and side surface Zulu X-ray. The side molecule is pointed by red cycles. It's easy to see a difference of distance passed by molecule along axis Zulu and axis Yankee by same spinning period. This would be the key moment in the future. Let's spin our flywheel clockwise and apply torque on top on direction of axis X and bottom in opposite direction. What happens after molecules turn on 30 degrees? So molecule at angle 0 degrees, which is on top, shift to angle 30 degrees, and its speed in torque direction decreased as the radius decreased. That means this molecule decelerate in speed vector direction or accelerate in opposite direction. And Next molecular at angle 30 degrees shift to angle 60 degrees, and its speed decreased as the radius decreased, same, but we can see on the sketch the acceleration vector getting large, more large. A molecular at angle 60 degrees shift to angle 90 degrees and reach the axis, and radius becomes 0, so molecular stop moving in the previous direction, and speed decrease, and we can see the length of vector of acceleration getting much bigger. And molecular which was on the angle 90 degrees shift to angle 120 degrees, and speed increased. Speed started increasing, so, and acceleration vector is looking the same direction. And molecular at 120 degrees shift to angle 150 degrees, the speed increased, and molecular also accelerating, but we can see the vector is getting smaller. And molecular at angle 150 degrees shift to angle 180 degrees, and speed increase also the same direction, but vector length is minimum. Let's take a look at the spinning disk with in motion. Let's go. So in reality, outer force can apply its force not exactly with axis in the center of the flywheel, so I consider case when the torque center is outside the flywheel or anywhere inside the flywheel, so the acceleration of the vectors in principle remains the same, and the molecule is accelerating in the same direction, and also in the center the acceleration is much bigger, and I consider the flywheel is a rigid body. This rigid body forces molecules to accelerate. Now it's your time to remember Newton's third law of motion, and for this law I assume first body is a flywheel minus molecular, and the second body is molecular. And third Newton's law of motion sounds: when one body exerts force on a second body, the second body simultaneously exerts a force equal in magnitude and opposite in direction on the first body. Now we can see the acceleration and reaction. As we can see on the diagram, molecular acceleration and therefore reaction on spinning body has not the linear shape. This is because spinning speed is constant, but radius of molecular at torque axis Zulu is projection. From spin axis follows the cosinus function, and acceleration of molecular is defined by derivation of radius, which is the sinus function with negative sign. Acceleration and therefore reaction force of molecules applied on spinning body has sinusoidal shape, and maximum is at right angle, 30 degrees from torque point at spin axis level. In this example iteration, the interval was taken as a 30 degrees angle of spin, and it's just for visual understanding. At real, the minimum interval should be taken. Acceleration on molecular level will start on distances comparable with intermolecular distances. And as far as our spinning body have symmetrical shape, the vector sum of the forces caused by acceleration shall be the same at 90 degrees from torque point at spin axis level ahead of spin direction. And now I want to present some living example. What happens? The tennis racket. The tennis racket is a really example we can meet in life. When we kick the ball, we do two things. We are stop the ball flying in, that means rapid deceleration, and push it in opposite direction. This is rapid acceleration in opposite direction. So deceleration is the same as acceleration in the opposite side. And this means that we accelerate the ball when we stop the ball, and when we push the ball, we're accelerating in the opposite side. And the tennis racket have square shape and handle. And the tennis player must have very trained hands to resist torque, which rise when the ball touches racket canvas, not at the vertical axis. If ball contact with the racket in the side area, strong torque appears. Same happens with our molecules in our spinning disk. Exposing acceleration will position it outside of torque surface. And now discuss how the force is distributed between two axes. As molecule with which expressing acceleration and exerting reaction force in opposite direction is in motion. The molecule is not exactly at the torque surface. The Zulu X-ray, its reaction force distributed between the two directions, axis Zulu and axis Yankee. On axis Zulu, they distribute by cosinus function, and on axis Yankee by sinus function. So, therefore, to define a force which applied on axis Zulu and Yankee, we take into account also acceleration, sinusoidal function, and so the formula will be force multiplied cosinus alpha multiplies sinus alpha for axis Zulu, and force multiplies sinus alpha and multiplies sinus alpha and axis Yankee. And now this is very interesting thing starting. In order to find the sum of forces on flywheel, we must integrate these functions. And integration shows the next figures. The force on axis Yankee is equal to P divided 2. This is around 1.57. And force which is on initial axis of the torque on axis Zulu is equal 1. Wow! So now torque distribute with the following proportion. It's 0.611 of the force is going to surface X-ray Yankee. This is precession, and only 0.389 of the force remain for inertia on surface Zulu X-ray, which is initial torque, the surface where initial torque force was applied. That shows that torque inertia are mostly going to precession. And what does this mean? This means what actually we can see. The torque inertia rapidly damping, and when force not applied, the torque stops almost instantly. In order to create the torque, the force must be applied all time. And force at right angle from applied force ahead of rotation direction, what is called precession, is stronger than at torque point by P divided 2 times 1.57. And now conclusion of the first part. Okay, now I understand how this force, which is called precession, generated. but it still not explains behavior of spinning top toy, gyroscope, or spinning bicycle wheel which hanging on a rope from one side. Now it's time to go to part 2, which is named as 4 precessions theory. I hope it will make all clear. Part 2, 4 precessions theory. And 4 precessions theory, it is very simple and very easy. When torque applied on spinning flywheel, any spinning body, it induced precession. Yes, it was described in part 1 of this presentation. And if spinning body is free to follow precession force, is free to turn, it starts to torque at 90 degrees ahead of spin direction. And this is the just first precession. And as we know from a rule that torque induces precession, and no matter what force induces it, outer or inner, the first precession induces second precession at 19 degrees from first precession ahead on spin direction. And this angle is 180 degrees from the point of applied force. Second precession also is free to turn induce third precession, which is 90 degrees ahead on spin direction, or it is 270 degrees from the outer force position. And third precession induces the fourth precession, same 90 degrees ahead of spin direction, and the fourth precession is the same direction as the outer force. Now look at the pictures. Yeah, this is first precession. This precession is fresh, and the force of first precession is depending on the outer force. This is very important also when axis of outer torque can be anywhere. What we discussed before, the first precession will start torque exactly around the axis of spinning axis, or the center of gravity. The second precession force direction is opposite to the outer force, and this precession is exactly the precession which do not let flywheel or bicycle wheel hanging on a rope to fall down. Doing this hard job, the second precession is losing its force. The third precession force direction is opposite to the first precession. Its force gets weaker than first precession on spinning top, because the second precession loses power for resisting the gravity. And when we see the spinning top slightly rotating, that means this is difference between first precession and third precession. And fourth precession is acting and increasing the force of initial force. And some important notes about four precessions theory. So any blocking of or obstructing one of the precessions will cancel or reduce all sequential precessions. I mean, if our spinning body cannot rotate in one direction, so all sequential precessions will be cancelled. And second note, any additional force added to precession will increase all sequential precessions. And now we can explain the events, what happens with the gyroscope, the stability of gyroscope, what is called a phenomenon of gyroscope. This is easy to understand it. Explained by four precessions. Any outer force induces first precession. The first precession induces second precession, which neutralize the outer force. And third precession will neutralize the first precession, and the spinning body will maintain initial position. That's all. Now we can explain the bicycle wheel hanging on a rope. What happens with it? This is a wheel is fixed only at one end on axis and resists the gravity. This is nothing above the second precession. And rotation of on first precession direction is difference between first and third precessions. If to hang some weight at the free end of axis, what we can see in many experiments, the speed of rotating will increase. That happens because additional weight reduces third precession, which is depending on losing of second precession's force. When we put more weight and second precession losing more force to resist more weight. But increasing of rotation increases second precession. This is magical. And when we have more weight in direction of first precession, the fly will start moving faster, and this will increase second precession, which resists the gravity. And this makes the wheel maintaining the angle, the same angle of the Earth. And also it's very interesting the spinning top with a white rounded end. When it was turned, this spinning top is turning upside down and spinning normally in upside down position. An explanation is that when gravity tilts the toy, white part is contacting with the surface and forced to rotate it in the direction of third precession. And third precession increases force precession, which is work together with gravity, and this gravity force is increasing and it's turning it upside down. But when white parts stop contact with the surface, it starts turning like normal top toy, spinning top toy. And I have conclusion. The examples listed here, this is only a few of many that can be easy and clear explained by 4 precessions. Not only mechanical, because spinning is everywhere in the universe. It's including macro world, the planets, stars, the galaxies, and micro world, including even electromagnetic waves. It's very interesting is electric and magnetic fields have difference, also 90 degrees, and something in this is inside the precession. Okay, thank you for your time, and new studies are going underway